Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future today. Imagine this, you tell your AI assistant, go buy me a used car, but don't overpay. It doesn't just click buy now, it negotiates back and forth strategically, like a human would. That's exactly what this paper explores. Today, we're diving into AgenticPay, a multi agent LLM negotiation system for buyer seller transactions by Shanyang Liu and Shangding Gu. And this paper asks a powerful question: can large language models actually function as autonomous economic agents? We already know LLMs can write code, summarize text, answer questions, but negotiation, that's different. It's not just reasoning, it's strategy, it's private information, it's long term planning. Most existing benchmarks test single agent reasoning, tool use, or simplified numeric auctions. But real world negotiation isn't just numbers, it's multi round dialogue, hidden reservation prices, different products, competing buyers and sellers. And until now, there wasn't a principled way to test that. That's the gap AgenticPay fills. Here's how AgenticPay works. It models negotiation as a language game. You have buyers, sellers, products, and shared market context. Each buyer has a private maximum willingness to pay. Each seller has a private minimum acceptable price. These values are hidden. They negotiate through natural language. Each round, buyer sends a message, seller replies. And critically, every message must include a structured price format like buyer price. A parser extracts that, and the system checks, is this price inside the bargaining zone? If both propose the same acceptable price, deal is made. If they exceed 20 rounds, timeout. So dialogue directly determines structured economic outcomes. That's the key innovation. Agentic Pay doesn't stop at one buyer and one seller. It scales complexity across three dimensions: number of buyers, number of sellers, number of products. It includes bilateral negotiation, buyer competition, seller competition, full many to many markets across 111 total tasks. And it spans 10 real business scenarios: used cars, SaaS procurement, luxury watches, even business acquisition up to 120K. It's not a toy benchmark, it's an economic simulation environment. Now, here's where it gets elegant. They don't just measure did a deal happen, they measure global score, overall fairness and efficiency, buyer score, seller score. The scoring normalizes surplus within the bargaining zone. There's a symmetric quality term, 4x, buyer utility, x seller utility, that peaks when surplus is split evenly. There's also a discount factor. Faster deals score higher, deadlocks get penalized. So the system rewards not just agreement, but balanced and efficient agreement. Then they benchmark major models: Claude Opus 4.5, GPT 5.2, Gemini 3 Flash, Qwen 3.14b, Llama 3.1-8b. The results? Frontier proprietary models dominate. Claude scores nearly 87 global score with 100% deal rate. Open weight models struggle. Llama 3.18b times out nearly half the time. And here's something fascinating: all models perform better as sellers than buyers. There's a consistent buyer disadvantage, possibly because training data contains more persuasive selling language than strategic buying guidance. That's a deep insight. Even more interesting, performance improves in multi agent markets. More buyers and sellers actually increase efficiency. Why? Market liquidity. More options lead to faster convergence. But financial asset negotiations, those expose weaknesses. They require deeper reasoning about risk and value, and models degrade significantly there. Agentic Py establishes something foundational: a controlled, scalable testbed for language based economic interaction. It reveals strong text generation is not the same as strategic negotiation, and there's a final caution. Automated bargaining systems could disadvantage humans. So, this isn't just about capability, it's about responsible deployment. Next question is even bigger. What happens when AI agents start negotiating with each other at scale? That future might be closer than we think. If you found this helpful, hit like, subscribe, and comment which AI system you want to build next. Stay sparked. See you in the next video.